RBS Business Research Academy welcomes you in the lecture number 41. In this lecture number 41, I have discussed how we can understand the concept of the R square, F square, and the Q square. Dear researcher, whenever we go through any research paper, any dissertation, so we have to encounter these type of the concepts over there. Almost every software they are producing these type of concepts, these are the values, so which we have to understand. Sometimes it's very difficult to understand the concepts of the R square, F square, and the Q square. So it is better to understand clearly so that's why this video is here. So in this video, firstly, I have provided all the theoretical concepts of the R, F, and Q square, and practically at the end of this video I have discussed how we can compute R, F, and Q squares in the SmartPLS 4. So let us start this video, but to understand how we can to understand the concept and practically how we can perform these things in the SmartPLS 4. But before this one, my name is Dr. Rahim Sumro, and I'm working as a professor at Shabti University, Pakistan. So here you're looking my certificate, which was awarded by the SmartPLS Academy. And then, so the first of all, the concept of the R square. So what is R? Normally, we are going across this concept. Normally, with the R square being produced. So now R square is the goodness of the fit measure for the linear regression model. So whenever we are applying linear regression model, it always produces the R square. So now, basically, when you talk about the structural equation modeling is also it's a combination of the factor analysis and the regression. So now that's why it is producing the R square, which checks the goodness of the fit. And R square, we can say R square only, or alternatively we can also call it the coefficient of determination. Now indicates a percentage of the variance in the dependent variable that independent variable can explain collectively. When you combine collectively all the independent variable, how much they are sharing the variance in the dependent variable, that's called R square. R square statistic explain the variance in the endogenous dependent variable explained by the exogenous variable or just variable, or by the few variables are there, like the two or more than two independent variable are there. Even you will get the value of the R square, even though if there is only one independent variable and one dependent variable, even though you will get also the value of the R square. Basically, R square means strength of the relationship between your model and the dependent variable. So its range is from 0 to 100. If 0 is there, the value of the R square is 0. That means that all the independent variables, they are not contributing any variance, any share in the any variability in the model. If there's 100% there, all the independent variables, they are fully explaining the dependent variable. I think there is no need to add more independent variable in the model, because already the 100% has been achieved. But it's very rare in our social sciences, because so many variables are there, independent variable, which we forget or which we cannot add in our model. So that's why it's very hard to get the 100% R square. So further, if we talk about the R square, the value influenced by the variable y, or we can say the dependent variable influenced by the x1, x2, x3, and x4. And the total variance of all these is a 4.473. Alternative, we can call 47.3 variation is being contributed by the independent variable x1, 2, 3, and 4. And to interpret, we have to look the arrow. It means the pointation of the arrow, where from the arrow which is coming from the, and where it is pointing out. Where it is pointing out, that is our dependent variable, and from where it is coming, it is an independent variable. So here you're looking here. So this one is a like the model. This is smart city is our dependent variable, and all these are our independent variables. So now total variance is being shared by all independent variable is the 0.73. We can say 73.3% is a good contribution by the all the independent variable, but it's still unique. It's not one. That means it's still some other independent variable are also required to aid in this one. If you will add any one more relevant independent variable, then probably the R square value should be higher than 0.733 in the model. So now you're looking here at the model, this one arrow. So pointation of arrow. So now this is our independent variable and this is our dependent variable. So see the pointation of the arrow. So now this one is also another model. So all these values are the R square values because these are a dependent variable and this one is an independent variable and this is completely dependent variable. So but these three are sometimes they are playing the role of the dependent and sometimes they are playing the role of the independent. For example, perceived use of ease of use. This is independent. Its dependent variable is perceived usefulness because you're looking the arrow pointation of arrow is coming from the perceived ease of use to perceived usefulness. And then here, this is another path which is going from the perceived usefulness to the behavioral intention to use. So here, this one is a dependent variable and this one is a dependent as well as independent variable. Independent are exogenous variable for behavioral intention and the endogenous are dependent variable for the perceived value. So that's why dual role has to play by this one and this one and this one. So that's why you're looking the R square are there. This has to play only single role of the being a dependent variable and this one is only independent variable. So if you talk about the values, so the Cohen suggests that the R square value are the 0.26 substantial, 0.313 moderate, and more than 0.02 is a weak. So although the variance is being shared by all the independent variable, but the value of this one it is less than that means 0.3, that is okay, it's a weak, but less than 0.02 it means there is no any contribution of the all the variables in the independent variable in the dependent variable. And the Chin proposed that the 67 are sorry 0.67 is substantial, 0.33 is a moderate, and the 0.919 is a weak. Here at all has I think here it has provided some logical like the values of the R squared where the 0.75 75% substantial, 50% moderate, and the 25% weak. Fogg and Miller is very generous in this regard. He says that if the R squared more than 10% or zero point 0.1, that means the endogenous, that means it's a recommended is a good R squared value. So now here looking R square independent interpretation. R square if it's equal to 1, you are looking at all the values of the independent variable, they are lying on the dependent variable line. So if the 0.83% is there, they somehow they are deviating from the main line. That means these are the values of independent variable. But when R square is 0, that means that they are much away from their line. So practical work. So now you can watch the at the end of this video. I have provided all the practical work how we can compute the R square. Then another the Q square. In addition to the size of the R square, predicted relevance, predictive sample reuse technique Q square we have also to apply to get the value of the predicted relevance. Either the relevant is relevant or not. Q square shows that how well data collected empirically can be reconstructed with the help of the model and the PLS parameters. It's another need of the Q square. Q square is a predicted relevance, whether the model has a predicted relevance or not. So its value is more than 0. So now the relevance has been intacted. And further, Q square established the predicted relevance of the endogenous construct. So endogenous means the dependent variable. Q square value above 0 indicate that your values are well reconstructed and that the model has a predicted relevance. Just if it is a more than 0. Wonderful. Okay, and then how to compute Q square. So in the SmartPLS 3, we were using the blindfolding procedure to get the value of the Q square. But now, as we are using the SmartPLS 4, in this one, they have ceased to use the blindfolding procedure in the PLS predicts. So that's why now they have introduced another algorithm that is called the PLS predict. Here you are looking PLS predict. So if you click it, then the software will provide you the value of the Q square. So now let me say, just like we are going on the website of the, for example, we are here on the website of this official website of SmartPLS. Okay, here you're looking regarding the blindfolding. They are writing that we have discontinued support for the blindfolding SmartPLS 4 and remove the algorithm. So now there is no further support for that means calculating, computing the blindfolding in the SmartPLS 4. So algorithm have also been removed, and alternatively they have provided the PLS predict. If you're interested, then the more the content is available, you can go through this content. Now, so Q square you're looking here, this is one model, so where all our independent variable are there, and this there like effect our beta values are there. So this is our IT continuous, this is our dependent variable, R square is 71, and the Q square is a 0.636, so much higher than 0. So in this way, you can report your Q square as well as your R square values in the model. So practical work, so you can go watch until the end of this video. So practical, we will get the practical work in SmartPLS 4. Last, that's about the F square. That means a variable in the structural model may be affected by the number of the different variables. It's true. That means whenever you are working on any model, so different variables are there. Somehow, sometimes independent dependent variable are there. Their impact is also on the dependent variable. So now, if we remove an endogenous means independent variable. If you are removing any independent variable from the model, then we have to check how much the R square has been changed. So now this is called the F square. This is called the effect size. So now effect size is a measure of the magnitude of the effect. So now if you're removing any independent variable from the model, then what is the magnitude of that effect? And then this measure is referred as F square effect size, increasingly encouraged by the general editor and reviewers. So normally it is in the demand by the general editors or reviewers that is a researcher that should also provide the value of the effect size or F square along with the R square. Their values are there 0.02 to 0.15. If it is, then the weak effect is there, but the effect is a weak. And if effect is a less than 0.02, it means there's no effect. If this is a 0.15 to 0.35, moderate effect is there you're looking, and if the higher than 0.35, strong effect is there. So now, we are going to perform all these things practically in SmartPLS. So here our model is there. So first of all, we are applying the model because all the latent variables are reflective in their nature. If you are unable to understand the difference between the reflective and formative latent variable, then my two videos are available. You can refer those two. Consistent PLS algorithm, and then just start calculation, and then these values are there. You're looking here. If you click here, just put the arrow here. The automatically one box is been appeared. So where the values are there. R square, R square, adjusted, composite reliability, AVR, all the values are there. So now these are our R square values. So now, because these three are independent variable as well as dependent variable, independent for the high performance and dependent variable for the privatization. So that's why you're looking the values are there. So now these R square. Alternatively, R square values are also available here. So these are the R square values which are available here. So now you can compare these R square values with the like the benchmark which I told you earlier. And then F square is also there. So these are the values of the F square. So now the greatest contribution is there of the LCS, which is 0.20. Okay, and MLQ has nothing, because if the value is less than 0.02, it means its effect size or F square is nothing. So now the beauty of software is that whenever there is no any violation, those will be shown to you either in the green or in the black color. Whenever there is a violation, that has been shown to you in the red color. Whenever the red color, you should be conscious. That means why there is an issue. So the issue is that means the MLQ's value is less than 0.02. So that's why it is nothing with you. If you delete this one, then you will see that means that there is no effect on the R square, or there will be no change in the R square. Let's see how it's being done. So first of all, we are going back, and then now this is our. So now you can remove this one, and this one. But if you remove this one, now this will become independent variable. Okay, but if you remove this one, even though this will remain dependent variable, and if you remove this one, this will become the independent variable. So that's why it is better to remove this one, and we want to check the impact of the when we remove this independent variable from the model. So now select it, and then no, we have to go back one step. Okay, now and read. You see, there is no impact. So before deleting this one, this path, the R square value was 0.69, and again it's the same. So now because its F square was very low, so that's why there is no impact. But instead of removing, if we remove this one, what's happened? Then we have to see it. Okay, so now we have to follow the same procedure again, because we removed the one indicator. That's why it's compelling to follow the same procedure again, but this time we are removing this item. Okay, so this time now look, check, please check, the 0.69 is a value of the R square, and then just remove it. Now you see it has become it has it's lowered down, and now it's just 0.62. Earlier it was 0.69. So this means that is the LCS has a very good impact. So now again I'm connecting this one, and okay, and then okay, yes, and then again come back, and then okay, the same procedure is there. This time we are reading what that the okay, this time what's happened? If you delete it, 0.69, now somehow there is a 0.68. There is a just 0.1% change is there in the R square. So now because the value of this one is LCS is greater, so that's why if you remove it from the model, there is a significant impact change in the R square. Okay, and then last but not the least, that's about the Q square. It's very easy to compute Q square. Just go into the PLS predict, and again I'm repeating just for information, in the SmartPLS 3 we were using the blindfolding technique algorithm. Just click it, everything is okay, start calculations, and then here a multivariate prediction summary, and then okay, not in this one, but if latent variable, okay, yes, sorry, in the latent variable prediction summary, you're looking the values of the Q square. It is very easy. If the value of the Q square is more than 0, that means that you should be happy. So the values of the Q square are much more than the 0, especially LCS is value is a 0.31, which is the highest in the here. So that means the Q square predicts the predictive capability of the all the variables has been established. So here, so all the concept I have discussed theoretically and performed practically. I hope you like this video. If you like this video, or if you have this video has clarified some of the concept regarding that these are R, F, and Q square, then please like this video, share this video, and comment on this video. Thank you very much for watching this video till end.